Today we are going to show you how to handle exponents that are fractions and tell you what those actually mean. So I have here a little, what I call cheat sheet. These are the numbers that you want to have memorized, and you've seen these before, most of them. These are your perfect squares. We've been working with these a lot this year, so hopefully most of them are familiar to you. And then we did some work with cubes, where we talked about 1 cubed, 2 cubed, 3 cubed, 4 cubed. And we said these numbers are special, so if you see them, you just want to recognize them as, hey, I think those are special. And then we have numbers that are perfect fourth power, so like 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, and typically don't go higher than that. Then we're getting pretty big. But those numbers are special. And then we have our perfect fifths. So like 2 to the fifth is 32, 3 to the fifth is 243, for example. Those numbers are special. And then we have sixth powers, which aren't as popular, but they pop up here and there. So like I said, I don't really see much of this. I see mostly fifth powers and below. But these numbers, and some of them are on multiple lists, like 64 appears a lot. So you just kind of want to keep a lookout for these numbers. They're going to pop up in the problems. All right, so when you have something that's raised to a power, you would call that whatever power it is, that is the type of root you have. So for example, if it said b squared, the opposite would be square root. If it said b cubed, the opposite would be cubed root. So we just say whatever the exponent is, that's the nth root of the answer. That's how you go backwards. Now we do have a name for this little n when we turn it into root form. So over here, if you look, in this form, n's the exponent, but in this form, that little n right here, that's called an index. The index is the type of root you're dealing with, and so far, all you guys have worked with are square roots and cubed roots. That's all we've done so far this year. The index of a square root, for example, is 2, and the index of a cubed root, for example, is 3. So this is a golden rule right here. So when you have a fractional exponent, it's really just a root. I always tell my students the top number stays in, the bottom number goes out. So the bottom is your type of root, and the top number, that's just the power of whatever's in the root. So we're just going to practice going from root form to exponent form. So we'll start with something very basic like the square root of 6. I'm going to add some numbers here that we don't see, but they're actually there. You know that 6 is the same thing as 6 to the first. We just never really write the 1. And square roots are the smallest type of root that's out there, so we don't have to put a little 2 here, but it really is there. So if you don't see anything, it's a square root. We already knew that. It's called a square root, and square means 2. So those numbers are actually there. So if I want to rewrite this as an exponent, it would be 6 to the 1 over 2 power, or 6 to the 1/2 is what I say. So again, the exponent stays on top and the type of root goes on the bottom. The next problem has x squared in a cubed root. That is the same thing as x to the 2/3 power. So again, 3 is the type of root, it's a cubed root, and 2 is just the exponent of the inside guy. So when I do letter C, this is a very common root, especially if you take pre-calc or trig. You're going to see something like this. You have to remember there's a 1 with this y. There's always a 1 there. So this is the exact same thing as y to the 1/3. So when I see y to the 1/3, I immediately think of this, cubed root y, the same thing. So like 1/2 means square root, 1/3 means cubed root, 1/4 means fourth root. They're the same thing. So it's just a representational thing. So likewise, this would be y to the 1/4 power. So we want to just be able to go from one form to another comfortably so that it's not so overwhelming to you. So this time we're going to go backwards. I'm going to give you the exponential forms and you're going to give me the root forms. So we're going to start very simple. The bottom number is the type of root. So bottom, out, top, in. Now there's two ways you could go about this. you can either put the squared on the end outside like this, or you can put the squared inside with the 8. It does not matter. So there's actually two ways you can handle this problem. We can either do the cubed root of 8 first and get 2, and then we'll have to square that because we didn't use that little square yet. Or we can do 8 squared first and then cube root that. Either way, you're going to get 4. So it does not matter if you apply the root or the exponent first, you're going to get the same outcome. We did 6 to the 1/2, so again, it's a square root. That's what the 2 means. And it's just 6 to the 1st when we don't need to write the numbers. So when I see 12 to the 1/2, I think square root 12. And we should know that we can't leave that like that. We would want to change that to 2 root 3. Then we have a 1/4 power. So our index is 4 and our exponent is 1. And then one more time, our index is 3, our exponent is 1. Now we can do the cubed root of 64. That was on that cube list on the other page. So you want to simplify them if you can. The cubed root of 64 is 4. The more you work with these numbers, the more you memorize them and you start to become familiar with them. So I want to show you how you can go about doing these with no calculator. And I want to caution you, if you're going to do this without calculator, you would want to have this chart handy. This has all your special numbers on it, and there's no way you have all these memorized yet. So you would want to have this so that you could do those problems until you get them memorized. Then obviously you wouldn't need it anymore. So let's pretend you have that sheet right in front of you and you're going to use it. So the first thing you're going to want to do is change all of these to root form. It's way easier. So the first thing I'm going to do is change this to square root of 4 cubed. Now, again, you can do the square root of 4 first, or you can do 4 cubed. It does not matter. For me, I like to keep my numbers small. So the square root of 4, well, that's just 2. And 2 cubed, that's just 8. So it's pretty easy to do it that way. Letter I don't really think you have much other choice. It is the 5th root of 32 to the 4th. I don't think you're going to want to do 32 to the 4th without a calculator. So it would be wise to do the 5th root of 32. That is on your number sheet in the 5th power box. So 2 is the 5th root of 32. And now I'll use the exponent of 4, and my answer is 16. All right, then it gets even crazier. So you have the 4th root of 625 cubed. You're definitely not going to do 625 cubed first. That's insanely huge. So we're going to do the 4th root first. We're going to apply the root first. And if we were to check our number sheet, 625 would become 5. Then I use the cube and I get 125. 49, I realize that's a special number, so that would be one probably you could handle right now. So we first rewrite it, and it's probably easier to do the square root of 49 first. I would change that to 7 and then apply the cubed. And 7 cubed, if you don't have it memorized, is 343. And then letter L, we're going to rewrite it, decide what makes more sense. We definitely want to do the root part first. And actually a lot of students do remember 125 becomes 5. And then 5 to the 4th. That one might take a little practice. It's 625. But again, all of these numbers are on your special numbers chart. So, you can have that out for reference as you do these until you get comfortable with the numbers. So in my next video, I want to talk about what do we do when we have negatives in our exponents? How do we handle that? So when you're ready, go ahead on to the next video.